Hello everyone, welcome to Vedantu Malayalam channel. This is Sana Khan, your maths master teacher from Vedantu. And how are you guys doing? Welcome back to the relations and functions series going on. So basically, in our limitless series, we are helping you prepare for your plus 2 sorry plus 2 maths, physics, chemistry and biology for not just your board exams but for every competitive exam that you are going to give this year, right? So with this one single series you will be prepared for everything, because we are basically do not just learning about basics, but we are doing every advanced topic, every single topic which has been covered or not covered by NCERT this year. We are doing it because that will be helpful for your competitive exam preparation as well, right? So yeah, good evening to all of you and welcome, and let's get started with today's lecture. So if you are somebody new on the channel, don't forget to subscribe, because if you don't subscribe, how will you attend the lectures and how will you come to know with all the upcoming amazing videos, right? So subscribe right now. Don't forget to hit the like button if you enjoy today's lecture, okay? And yeah, share the video with your friends too, so that they can also come and we can have fun together, right? Okay guys, so as you know that we have basically divided the chapter into 5 lectures, and we have already covered 2 lectures till now. So in lecture number 2, we have learned about relations, the different types of relations, reflexive, symmetric, transitive relations, and equivalence relationship, right? So this is all what we learned in lecture number 2. I hope you guys remember it very well. If not, then do watch that lecture because if you don't know about relations, it will be a little difficult to learn about functions, because functions are what? They are nothing but relations. Do you know that? Okay, let's learn about them in detail. So today we are going to learn about functions, which are nothing but a special type of relation. Then we will also learn about their domain, range, codomain, and the different types of functions that we have, because this is one of the most important topic mostly asked in your Kerala board or CBSE board exam. Alright, so yeah, once again, very warm welcome. Don't forget to hit the like button and mark your attendance, and let's get started. So, what do you think a function can be? Can you imagine a function to be something like, we have generally seen it looks something like that. But what is it? What is f of x? What does it do? And what is the use of it? Any idea? Any idea? Chalo. Let's learn it in a different way. Okay. Have you guys seen the magic hat trick? The magic hat. How many of you know the magic hat trick? What happens is, if you put a carrot inside the magic hat, a rabbit comes out of it. Have you seen that magic? Or if you put an egg inside a magic hat, a pigeon comes flying out of it. You might have seen this classic example of magic trick, right? So similarly, let us consider functions to be like a magic box. Okay, so what are functions? Functions are like magic box. Now suppose my magic box is doing what? It is taking 4 as input. It is returning 16 as output. Okay. Similarly, if I put 3 as input, it is returning 9 as output. So basically, can you guys understand here what your magic box is doing? Can you guys understand what is your magic box doing? Anyone? Hi Nila, welcome. What is my magic box doing here? So my magic box is nothing but taking a number and squaring it. Taking a number and squaring it. So this magic box must contain a square function inside it, right? So function is nothing but like a magic box. You put something, you get something. And it absolutely depends on what is the magic going on inside the box. That magic is nothing but the function. Okay. So what is a function? A function is nothing but a relation that maps each element x of a set A with one and only one element y of another set B. So suppose you have a set A and you have a set B. Okay. Suppose you have a function x cube. So any element of set A will go to fx and then fx will return one output which it will be mapping it. So one output will be 1, 2 will become 2 to the 4, 4 to the 8, 3 will become 3 will go to fx will make it 27. So what is my function? My function is basically a relation that is mapping a number from set A to a number from set B. Therefore, the function here is returning me ordered pairs that when I put 1, I get 1. When I put 2, I get 8. When I put 3, I get 27. So this type of relation, when I put something, get something, but always the relation remains same. What is the relation here? The relation is x cube. And this relation is called as a function. Everybody understood what is a function? So a function is either an operation or an expression which basically maps one element of set A with another element of set B together and return you ordered pairs. Clear to everybody what a function does and how it works? Okay, now to understand it better, let us understand domain, range and codomain of a function. Okay, now just now we have seen an example that if my function is x cube, it will take 1, 2, 3. This is basically my input and it is returning some output. Now basically the output can contain a lot of numbers. So let me take here x square, suppose. So output can be 1, 2, 3, 4, 5, 6, 7, 8, 9 and so on. All the numbers. Okay. So what my function is doing, 1 square, 1, 2 square, 4, 3 square, 9. So what my function is doing basically, it is taking one number and it is mapping it to some other number. Okay. So here in this picture, these input numbers are nothing but your domain. So what is domain? Your domain is your input numbers. Clear? Okay. Now the same example, what is range? Range is basically the output numbers. So if my function is x square, so I am getting a set where 1 square is 1, 2 square is 4, 3 square is 9, 4 square is 16. So here my range is basically what? Output 1, 4, 9, 16. So this is basically my range. And what is my codomain? Codomain is basically the set of all possible outcomes. So looking at the same example 1, 2, 3, 4, 5, 6, 7. Here also I have 1, 2, 3, 4, 5, 6, 7, 8. Whatever. 1 is mapped to 1. 2 is mapped to 4. 3 is mapped to 9. Okay. So here my range is 1, 4, 9, 16. But my codomain is what? Codomain is all the output. So does not matter it is mapped or not mapped. There is a link or there is no link. Does not matter. All the output is my codomain. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All the numbers given here are the codomain. Okay. So basically if you look at this picture, it is simpler to write this circle is your codomain and this circle is your domain. Understood everybody? What is domain? What is codomain? Hi Krishna Veni, hi Vasant. Okay. And what is range? Range will include only the numbers which are mapping to some other number. Okay. Awesome. So this is domain, codomain and range of a function. So everybody understood what is function? Give me a thumbs up quickly if you have understood what is a function. Give me a thumbs up quickly. Come on. A thumbs up. Done. Understood what is function? Or just write done, 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 done. Yes. Cool. Thank you, Krishna. Okay. Now moving on to the different types of functions we have. Okay. There are a lot of different types of function. So basically we are going to learn about 4 of them. Okay. First one-to-one function. So what can be one-to-one function? Can you think? 1-to-1. Now, let's take a simple real life example. Okay. Suppose there is a car purchased in 2023. Now, you tell me that can one car have more than one number plate? Can one car have more than one number plate? Is it possible? Multiple numbers for a single car? Yes or no? Is it possible that there are multiple number plates for one single car? No, right? One car will have only one number plate. Now suppose we are writing here, one car is having CG001, one car is having DL007 Bond, and some car is having take TN 1234, anything like that. Okay. Now suppose there is one car Creta here, there is one car Thar here, there is one car. What is your favorite car? Tell me name of your favorite car. And don't write Ferrari and Bugatti and like that. Okay. Tell me your favorite car. You see. Quickly. Tell me one favorite car. PLM Tixik. Can you write in English, please? Because Audi. Okay, chalo. I'll put Audi here. Okay. So, is it possible that Creta, like suppose you have bought, like your father has bought a Creta. Okay. So, is it possible that front of your car has this number and back of your car has this number plate? Is it possible that your front and the back of the car has different number plate? No, it is not possible, right? One car can have only one number plate. Every car has only one number plate, right? So suppose Thar has this number plate, Audi has this number plate. So here we see that one car has only one number plate possible. This is one-to-one function. One input, only one output. One output, only one input. No other mapping possible. Okay. No other mapping possible. Okay. Similarly, if I ask you, is it possible that CG001 is of two car? Creta is also having CG001, Audi is also having CG001. Is it possible? Both the cars are having same number plate. Is it possible? Is it possible that you and your friend have ditto same to same number plate? Is it allowed in India by government? Is it allowed? It is not allowed. It is not possible that one number plate belongs to two different person. It is not possible. What if that person goes and does one accident, the blame will come on the other. It is not possible, right? So similarly, we have one-to-one function. It basically means that every input has only one output. Every output has only one input. Okay? No two outputs can have same input. No two inputs can have same output. Everybody understood what is one-to-one function? One car, only one number plate possible. One number plate, only one car possible. Neither of them can have many-to-one relationship. Only one-to-one relationship, that is called as one-to-one function. Okay. So if a function defined from A to B is such that for each element of A, there is a distinct element in set B. There is no double, triple elements matching to in set B. Okay. So then it is called as a one-to-one function. For example, if your function is 2x, then is it a one-to-one function? Yes. Why? Because suppose your input is 1, your output will be 2, because function is 2 times of x. 2 2s are 4, 3 3s are 9, 4 4s are 6, sorry, not 9. 2 2s are 4, 3 2s are 6, 4 2s are 8. So, one number is mapped to only one number. It is not possible that more than one number is mapping. है ना? It is not possible. If 2 into 2 is 4, is it possible that 3 into 2 is also 4? No, it is not possible. That is why it is a one-to-one function. One input has only one output. Clear to everybody? Okay. Now let us see how do we prove that it is a one-to-one function. What type of question will be asked from you in exam? No, not yet, Rishan. Suppose the function is defined from real numbers to real numbers such that f of a is 3a cube minus 4. Prove that it is a one-to-one function. Now, how do you prove that it is a one-to-one function? For this, you have to prove that if f of x1 is equal to f of x2, it implies that x1 is equal to x2. Then in this situation, we can call it as a one-one function. For example, suppose my function is this. Suppose I am saying that let two images are same. I am saying that if you input x and if you input y, the answer is coming same. So it is becoming many to one function, but it should not be possible in one-to-one function. Let's put the values here, okay? So I will put here, so it will become 3x cube minus 4, 3y cube minus 4. So minus 4 cancel. 3x cube is equal to 3y cube. 3 cancel. X cube is equal to y cube. So this implies that if you basically find cube root here, this implies that x is equal to y. So we are getting fx is equal to fy only when x is equal to y. This implies that f of a is a one-one function. Understood how we have to prove that it is a one-one function? If you're putting two different input but you are getting same output, then it is not 1-1. But here we have proved that f of x is equal to f of y only when x is equal to y. Therefore, my function is 1-1 only. My function is correct. It is not a many-to-one function. Okay. Chalo. Moving on to the next function, which is many-to-one function. Now, from the name itself, can you guess what the function says? So, it says that many input can connect to one output. For example, do you guys know these two people? Do you guys know these two people? Who are they? Do you know them? Hi, Amaljeet, welcome. Anyone? Do you know them? Hi, yellow man. Late today? Nobody knows them. Nobody knows them. Come on. Okay, I guess nobody knows their name. Okay, so I'll tell you their name. So basically, they are two famous actors, and the name is Shah Rukh Khan and Salman Khan. Okay, so let's take a very simple example. Can If my function is basically name, so can first name and last name be mapped together? When we are mapping them together, can multiple people map? Yes. So one person can be Shah Rukh, and Shah Rukh last name can be Khan. Another person can be Salman. Salman last name is Khan. Another person can be Sana, and that person's name can also be Khan. So Shah Rukh is also Khan, Salman is also Khan, Sana is also Khan. So that basically denotes what? It is nothing but many people are mapping to only one title, one last name. So that is what? That is many to one function. Many input is having only one output. Many inputs are mapping to single output. Such a function is a many to one function. Okay, can you think of an example in mathematics also? Yes, suppose A1 and A2, both of them are mapping to B1. So it is what? Is it 1 1 or many 1? It is a many to one function because both of two numbers are mapping to a single output. So it is a many to one function. For example, suppose I say that my function is x square. It is a many to one function. Can you guess why? Because when x is equal to -1, f of -1 is 1. When x is equal to +1, then f of -1 is also 1. See, for -1, it is 1. For +1, it is 1. For both of them, it is 1. So this is many to one function. It is not a one to one function. Understood? Everybody clear? So -1 +1. Both of them are mapping to 1. Similarly, -2 +2. Both of them are mapping to 4. So this is a many to one function. It's not a one to one function. Not one input, one output. Clear? Clear? Show some fire in the chat box, some fire, some crackers. If it is clear. Salman Khan, Shah Rukh Khan made everything clear. Okay. Okay, moving on to the third type of function. Okay, but before that, let's do one question of many to one function. Suppose you have input. This is your input 1, 2, 3, 4. This is your output set x, y, z. There is a function 1 with x, 2 with y, 3 with x, 4 with z. Is it a many to one function? Question mark. How will you prove it? Just write down set x, write down set y. 1, 2, 3, 4. X, Y, Z. Now read the question. What the question is mapping. How the question is mapping them. So when you look here, 1 with X, 1 with X, 2 with Y, 2 with Y, 3 with X, 3 is also mapped to X, and 4 with Z. Is it many to one function? Yes or no? It is many to one function, yes or no? Yes. It is many to one function. Why is it a many to one function? Because 1 is mapped to x and 3 is also mapped to x. So there are two input mapping to one output. So it is a many inputs, one output. Many to one function. Clear to everybody what is many to one function? Yes? Understood? I hope so. Okay. Let's learn about the third type of function we have. Into function. Now what is an into function? So there are two types of function basically. Into, onto. Into, onto. Now what is into onto? Suppose there is a family, it has like 3-4 members. Suppose in your family you have papa, you have mummy, okay, you have sister, you have brother, you have dadi, your grandmother, okay. Now every family member can have a favorite color. For example, here the colors are red, blue. Tell me your favorite color in the chat box. Black, pink. What is your favorite color, by the way? Tell me quickly. What is your favorite color? Suppose papa's favorite color is blue, mummy's favorite color is green, sister's favorite color is red, brother's favorite color is also green, and dadi's favorite color is pink. Okay, so everybody has chosen a favorite color. Now can you guys see that any color is left out or not? Is there a color who is left out, who is lonely, who is nobody's favorite? Is there any color who is nobody's favorite? Well, I can see here that black is nobody's favorite. Black is not mapped to anyone. है ना? Nobody is choosing black. Well, in the real world, it is not possible. Many people like black as their favorite color. But suppose that nobody likes black. So black is what? Left out. है ना? Black is alone. Nobody is choosing black. So in this situation, such type of function is called as into function. When your range is not equal to the codomain, when in the codomain somebody is left out, it is not mapped to any input, then such a function is called as into function. Clear to all of you? Okay, so here also see, A is mapped to 1, B is also mapping to 1, C is mapping to 2, 3 is lonely left out. So such an element, such a function is called as into function when your range is not equal to the codomain. Everybody clear? Okay, can you think of an example of such type of function? Quickly, can you think of any example? So suppose my function is defined from real numbers to real number. Okay, so here I am having 1, 2, 3, 4, 5, 6, 7, 8, all the real numbers. Here also I am having all the real number 1, 2, 3, 4, 5, 6, 7, 8. Now my function is f of x is 3x. So 1 3 is a 3, 3 3 is a 9, 2 3 is a 6. This is left out, left out, left out, left out. So this is what? Left out. It is not having any input mapped towards it. So it is an into function. Clear? Alright, let's see one question, one example. Let A be the set 1, 4, 7, 12. B be the set A, B, C, D, E, F. Quickly, let's draw this. This is set A, 1, 4, 7, 12. This is set B, A, B, C, D, E, F. My function is described as 1 with A, 4 with B, 12 with C, 7 with E, and 4 again with, 4 was mapped to B. Okay. So now, is there anyone left out? Is there anyone who is not having an input? So D is alone. F is alone. It is not having any input. So this is an into function. Why it is an into function? Because D and E are not mapped to any input. It is not mapped to any input. Clear to everybody what is into function? Now the last function that we have, onto function. So onto is reverse of into, right? So what is onto and into relationship? Very simple. See, suppose set A has roll number, set B has class 12 students. Okay. Now suppose I'm just writing down the random roll numbers like 1, 2, 3, 4, 5, 6, 7, 8. These are the roll numbers. Then let's write down some names here that one person is Rishan, one person is Vasant, one person is Krishna. Then we have Amaljeet. Then who else? Yellow Man, Nila. Okay. So suppose we have these people, these students of class 12. Okay. Now suppose if we look at the order, Amaljeet roll number will be 1 because his name starts with A. Then we will have Nila. No, we'll have Krishna. Then we will have Nila, roll number 3. Then we will have Rishan, roll number 4. Vasant, roll number 5. Yellow Man, roll number 6. And then some other students. So basically, every student will have a roll number, true or false. My question is, every student will have a roll number. Every student will have a roll number? Yes. If they don't have a roll number, then how will the teacher call the attendance, or how will you give the exam if you don't have the roll number in your admit card, right? So you must have a roll number, an identity number, an identity card number. You should have something, right? So every student will have a roll number, right? So is anyone left out? Anyone left out? No. Nobody is left out. All the names are mapped to some or the other number. No left out. No left out. So this is onto function. That all the elements are mapped to something. Such a function is called as onto function, where range is equal to the codomain of the function. So B1, B2, B3, B4, B5, everybody is mapped to somebody. Okay. Everybody is basically mapping to somebody in the input. So this is an onto function. Nobody is left out here. Alright. So for example, here they have given an example that set A has 1, minus 1, 2, 3. Set B has 1, 4, 9. So 1 with 1, minus 1 with 1, 2 with 4, 3 with 9. Everybody is mapped. So it is a onto function. Okay. Very good. So let's see here, how can we prove that a function is 1, 1 and onto. Suppose they are asking, let your function fx is x. Show that the function is 1, 1 and onto. Now, if my function is 1, 1, then basically one element should be mapped to only one element. Now, here it is clearly given f of x is basically equal to x. So, for every x in the output, there will be an f of x in the output. So, if the x is 1, output is 1. X is 2, output is 2. X is 3, output is 3. Because f of x is nothing but x. So, is it 1, 1 function? Yes, it is a 1, 1 function. Because if it is minus 1, output will be minus 1. It is not plus 1. So, every input is having one single output. So, it is a 1, 1 function. Similarly, is this onto function? Again, yes. Why? Because if my function is defined from real numbers to real numbers. Suppose I am taking the number minus 3, minus 2, minus 1, 0, 1, 2, 3, 4, 5. Similar here, minus 3, minus 2, minus 1, 0, 1, 2, 3, 4, 5. My function is f of x is equal to x. So, f of 0 will be 0. F of 1 is 1, 2 is 2, 3 will be 3, 4 will be 4, 5 will be 5, minus 1 will be minus 1, minus 2 will be minus 2, minus 3 will be minus 3. So, everybody is having an input, nobody left out, है ना? No element is left out. Therefore, onto function. Alright, now coming to the last typical function that we have called as bijective function. What is a bijective function? If your function is 1, 1 and onto, we call it as a bijective function. Just now we have seen f of x is equal to x. This function is 1, 1 and this function is onto. Such a function is called as bijective function. Clear? If your function is 1, 1 also, onto also, then only you call it bijective function. Okay? Now, what type of question will come in your exam? Let's have a look at that. First, let the function be defined from natural numbers to natural numbers given by f of x is 2x. Show that the function is 1, 1 but not onto. Okay, let's draw this. So it is having all the natural numbers. It is also having all the natural numbers. So 1, 2, 3, 4, 5, 6, 7, 8 and so on. Let's draw it here also. We are having all the natural number 1, 2, 3, 4, 5, 6, 7, 8. Now my function is 2x. What is my function? F of x is 2x. So 1 2s are 2, 2 2s are 4, 3 2s are 6, 4 2s are 8. Fine. Now, is it a 1 1 function? Yes. It is 1 1 function. So, if 1 is your input, 2 is the output. 2 is the input, 4 is the output. 3 is the input, 6 is the output. If your 4 is the input, 8 is the output. Similarly, 5 is the input, 10 is the output. So, 1 to 1 function. Nobody is matching here. You know? Every element is having only one output. So, it is 1 1 function. But is it an onto function? No, clearly not. This is alone, left out, left out, left out, left out. They are lonely, left out. Nobody is matching to them, right? So, basically, output has only even numbers. See, 2, 4, 6, 8, 10. Only even numbers are there. So, odd numbers have no input. So, it is a into function. It is not onto function. Okay. Next. Okay. So, here we have seen. Next is, if my function is x square, show that it is neither 1 1 nor onto. How is that possible? It is mapping from real numbers to real number. Real number is your input. Real number is your output. So again, -3, -2, -1, 0, 1, 2, 3, 4. -3, -2, -1, 0, 1, 2, 3, 4. My function is x square. So basically, here we have not written. -1 square is +1. -2 square is 4. -3 square is 9. 0 square 0. 1 square 1. 2 square 4. 3 square 9. So here we observe that my function f of x basically is a relation having -1 output is 1. +1 output is also 1. -2 output is 4. Okay. +2 output is also 4. So basically it is a many to one function. It is what? Many to one function. Because -1 is also 1 and +1 is also coming 1. So it is a many to one function. And it is an into function. Why it is an into function? Because this is alone, this is alone, this is alone. So negative numbers are never square of any number. Therefore, it is into function. It is not onto function. All right, clear to everybody? What is 1 1, many to one, into, onto? Okay, I hope it is clear. That's all about the different types of functions you have. But generally, there are some particular type of functions which you should know about because sometimes questions are asked from them. So just for your extra knowledge, I want to basically show you guys some typical type of functions which are there and how their graph looks like. That's all. That's like an extra information for you. But it is information because in many questions they will ask. So one such function is called as identity function. What is identity function? F of x is x. So basically f of 1 is 1. F of 2 is 2. So this is called as an identity function. The graph looks like this. Next is constant function. What is constant function? If f of x is some constant k. For example, f of x is 4.5. So if you put -1, you get 4.5, -2, 4.5, 6, 4.5, 12, 4.5. Nobody, no matter what your input is, your output is always same number. So that is a constant function. Okay. Next, polynomial function. So a function which can be expressed as a polynomial are polynomial function. For example, f of x, x square, f of x is 3x plus 4, f of x is 4x cube. This is what? Polynomial function. Okay. And lastly, modulus function is also very important. What is modulus function? So, for x greater than 0, f of x will be plus x. For x less than 0, f of x will be minus x. This is modulus function and the graph looks like this. Okay. Now sometimes they directly ask about these functions in the question. That's why I have told you about them also. Alright guys. So that's all for today. Let's summarize. What did we learn? So we have learned about the different types of functions. We have function is like a magic box. You put something, you get something out of it, right? So now the function can be of different type. It can be 1 to 1 if only one element is mapping to one element. Many to 1 if multiple elements are mapping to same element. Then into function if in the input some number is alone left out. Onto function if every input has one output, then it is an onto function. And bijective when it is 1 1 and onto both. If it is 1 1 and onto both, it will be called as bijective function. Alright, so these are the different types of functions in your syllabus. In the next lecture tomorrow 8 p.m. we are going to learn about composite function and inverse of a function. Okay, so composite and inverse of a function we are going to learn tomorrow 8 p.m. Okay, so be present in tomorrow's class too. Alright guys, so types of functions is completed. If you want notes of this lecture, quickly subscribe to our Vedantu Malayalam Telegram channel where we will provide you notes of every lecture, constant updates, notifications, assignments and much more interesting things over there. So do subscribe to it so that you keep getting all the notifications, session informations, everything time to time. Okay, so yeah guys, that's all for today's class. If you enjoyed it, don't forget to subscribe to our channel, like the video if it was useful for you and you enjoyed it, because today we learned everything with real life examples. So I hope that it must be crystal clear for you, right? So thank you so much for joining today's lecture. Hope you had fun. See you tomorrow in the next class. Bye guys. Bye-bye. Take care.